Okay, so today we're going to talk about relations and functions. First of all, everything's a relation pretty much that we study in math. And functions, first look at those three letters, fun, woo! Functions are special relations. So we're going to talk all about our functions and our relations today. And we've got this little definition here. You're going to want to write this one down. You know how when things are in boxes, they're important? Yeah. That's what we got going on here. So a relation is a set of x and y coordinates, and they can be written in different ways. Remember, when you graph, you have an x coordinate and a y coordinate. X tells you to go right if it's positive, left if it's negative. Y tells you to, after you go left or right, then go up or down depending on whether it's positive or negative. We have x values, and they have a special name. They are called the domain. And we have y values, and they have a special name. They are called the range. Here's some good news. They have other names too. The domain of a relation is all the x values. It is also called the input value. Because what happens in a relation is they're going to tell you what to do. They're going to tell you the rule of how you get from the beginning to the end. You're going to input an x value. It's going to go around and around and around inside the little function, and it's going to come out with the output, which means the range is also called the output values, okay? We also can go backwards. We can say, well, what if I do this and I can go this way and this way? That's called the inverse of a function. It's when the input and output values are switched. So basically, instead of xy, it's going to be yx. You're going to go backwards. So it can be written as a table, a graph, and a mapping. So first of all, this is our set of ordered pairs. Notice these little guys right here. That's called set notation. And we always want to write all of these relationships in set notation. So the domain is going to be in set notation, the range is going to be in set notation, and the inverse is going to be in set notation. Notice how they started out pretty nice and they've gotten pretty nasty. X is, remember, can be called the domain or the input. Those are two different words for x. And when I look at my ordered pairs, remember it goes x, comma, y. So when I look at these, my first x is -3. It matches with a y of 3. I have an x of -2, and it matches with a y. Well, that was -1, Goober. And it matches with a y of 2. I have an x of 1, and it pairs up with a y of 1. I have another x of 1, and this time it pairs up with a y of 3. I have another x of 3, and it has its little match. Its output value is -2. And an x of 4 gives me an output of -2. So the y values, remember, can be called the range, or they can be called the output. When I graph them, the domain tells you to go, whoops, that should have been blue, huh? The domain tells you to go right if it's positive, left if it's negative, and this is done first. See how the alphabetical order there? Blue comes before green, so you do the blue first. Thought about that myself. Range tells you after you've gone left or right, you go up if it's positive, down if it's negative. So for this -3, 3, I'm going to go left 3. I'm not going to stop there. I'm then going to go right 3, and that gives me, or up, I'm sorry, up 3. That gives me my ordered pair. It's kind of like directions. If I'm trying to tell you to get to the mall, you're not going to go left 3 blocks and then be at the mall. You're going to go left 3 blocks, then you're going to have to turn right, and then you're going to have to turn left, blah, 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 blah. So you don't actually stop until you finish all of the directions. So this one tells me left 1 and then up 2. So I'm going to go left 1, up 2. That's where my next point is. This is a positive 1, so I'm going to go right. Positive 1 says go up. So I'm going to go right 1, and then I'm going to go up 1. This is a positive again, so I'm going right 1. Then I have a positive 3, so I'm going up 3. Positive 3 says go right 3. Don't put it out there. I'm just showing you so that you can see, because you can't see my little fingers saying it goes over there. I wish you could. I wish you could see my little pen. I see a little pen. Maybe you do. I don't know. 2 this time is negative, so I'm going to go down 2 before I stop. 4 is positive, so I would go right 4, so I'm sitting right there right now. And then 2 is negative, so I'm going to go down 2. For a mapping, you're going to label this one domain with a D and this one range. Look at these, look like Twinkies, don't they? I like Twinkies. That'll be our secret word for the day. Twinkies. Alrighty. For the domain and the range, it's really important that you just list, come on pen, pen's not working. List the values. You list what values are in the domain or in the range. You do not tell me how many times they show up. So for example, I've got a -3, then I have a -1, then I have a 1. This one also shows up, but I've already told you one's in the domain. So then I have a 3, and then I have a 4. So don't repeat values in the domain. For the range, I have a 3, then a 2, then a 1. I've already got 3, so I don't have to repeat it. -2, I've already got -2, so I don't have to repeat it. Now, some teachers will tell you those have to be in numerical order. I'm not one of those. I'm just going to tell you I want them listed, okay? Then you're going to map. You're going to tell me what input gives you what output. So what this tells me is when I input -3, I get an output of 3. So -3 maps to or gives me 3. -1 maps to 2. 1 maps to 1, so that's this one. Oh, look, 1 also maps up here to 3. I do have to map it both times. I just don't write the 1 twice. 3 maps to -2, and then 4 also maps to -2. This is actually my personal favorite way to see it because I can see real clearly that 1 has 2 little outputs. I can get a 3 or a 1. So it's like if I push, I'm at a soda machine and I push Coke, I should get a Coke, but guess what? Sometimes I get a Coke and a Dr. Pepper. Okay, I don't know if Coke makes Dr. Pepper. Just go with me on that, okay? I don't know. So domain. The domain again is just a list. The nice thing is it's your domain Twinkie. It's just a list. It is not how many times they show up. The range, we had a 3, a 2, a 1, and a -2. We don't write the 3 twice, and we don't write the -2 twice. We just say how many or what numbers are in there, not how many times they show up. The inverse, I just switch. My input becomes my output becomes my input. So for this first one up here, I'm going to put 3, -3. For the next one, it's going to be 2, -1. Flip your input output. Then I have 1, 1. Then I have 3, 1. Then I have -2, 3. And -2, 4. Keep your set notation. Okay, your turn, your turn. You might have to flip back to the previous slide to actually see what you're doing. This one, oh my goodness, these dots did not show up where they were supposed to be. So let's move this dot, make it a little bigger. If they don't go where they're supposed to be, we make them a little bigger. Let's put them there, there. Let's move this one right there, and that one's actually good. Okay, so I want them written as a set of ordered pairs, and then you're going to write the inverse. So first you're going to give me the ordered pairs. So the ordered pairs, and then you're going to write the inverse. Okay, you're going to do it 1, 2, 3 times. Pause the video. Oh wait, this is an example. This isn't an output. That's silly. I thought it was an output. All right, so let's write our ordered pairs here. Is the next one an output? I don't know. I can't see the slide. So our ordered pairs are x, y, x, y, x, y. What's our inverse? Remember the inverse is y, x. y comma x, y comma x. Okay, this one I'm going to put it down here. My ordered pairs, now watch how this goes. 3, follow the arrow, goes with 8. 5, follow the arrow, has an output of 6. 2, oh my goodness, this did not transfer well. 2 is supposed to go to an input, or negative 2 goes into an output of 5. And then 0 has an output of negative 7. So what this tells me is my little snipping tool did not work well, did it? That's sad. All right, my inverse, we just reverse them. It's going to be 8, 3, 6, 5, 5, negative 2, negative 7, 0. Good idea writing really big, Mrs. Evans, because now you have a whole nother problem to do. So here, my ordered pairs, I'm just going to start with this one right here. It's left 2, so that's negative 2, and then up 1, 2, 3, 4. Now I'm going to go to this one, okay? It's right 2, so that's a positive 2, down 1. Negative is a direction, down 1. Go to this one next. It's right 3, so that's a positive 3, down 2, so that's a negative 2. Oh, this is going to get a little squishy. This one I go right 1, 2, 3, 4, so that's a positive 4. And then I go up 1, 2, 3, 4, 5, so that's a positive 5. Positive is right or up, negative is left or down. Inverse, I just flip them. Yx, 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 Yx. Okay, I should have redone this video because I gave you lousy directions at the beginning, but you know what? I messed up every now and then. Human. Okay, so now we want to determine whether the following relations are functions, which means we need to take a minute and we need to actually define a function. So everybody write down function. You're going to have fun while you're doing this. A function is a relation where no x value repeats. So for every input, there's only exactly one output. Let's look at what I mean. This 1 has an output of 3. If I say what goes with 3, you can tell me it's 8. If I say what goes with 4, you can tell me it's 3. If I say what goes with 7, you can tell me it's 2. So this is a function because if I give you an x value, you know for sure what y value it goes with. Look at b, however. If I say what goes with negative 2, what's negative 2 friend? What's its output? You know it's 1. But if I say what goes with 3, look at how you have two options. You might say 5, you might say 3. So that tells me right there it is not a function, okay? It is a relation. Any input-output is a relation, but it's not a function because this 3 is repeated. If I say 3, you do not know what I get. So that's like if I push Coke, I better get Coke. But if I push Coke and I get Dr. Pepper, it's not functioning correctly. So when you push 3, what do you get? You could get 5. Pen's not writing again. Or you could get 3. So because that input has two different outputs, it's not a function. So on this one, I'm looking. I've got a 1, a negative 3, a 4, a negative 2, and a negative 4. So if I say 1, do you know what its output is? Yes, 5. If I say negative 3, do you know its output? Yes, 6. If I say 4, do you know its output? Yes, 6. Negative 2, yes, 5. Negative 4, yes, 5. Some of you might say, but look, the output's repeated. Don't care. If I have a soda machine, is there always only one button that says Coke? Sometimes I can push that button or I can push that button and I still get the same output and it's still functioning. So the output can be repeated, the input cannot. So that one, the first one's a function and the last one's a function. No x values repeat. All right, there is also a way to test the graphs. It's called the vertical line test. A function, write this down, will pass the vertical line test. So what this means is if you had a piece of spaghetti or a pencil and you started with your pencil or your spaghetti vertical like that and you just kept running it through the graph, it would never touch the graph twice. So look at this. Do any one of those vertical lines touch the graph twice? No. This is a function. Look at what happens on the circle. Oh my gosh, oh my gosh, oh my gosh, oh my gosh. Do you see how that same vertical line touches the graph twice? That means that x value has two inputs. Let's pretend this was actually on 2. That would have been smart if I'd have done that. If I say what goes with 2, 2 could go up here with 3, or if I push 2, I could get -3. So this is not a function. It fails, and we call it the VLT, vertical line test. How about this one? Does it pass? Sure does. That one's a function. How about this last one? Does it pass? Sure does. That one's a function. I like the vertical line test. It's pretty easy peasy lemon squeezy. Okay, then we have this new concept. This is kind of, guess what this gets? This gets a biggie wow wow star. Function notation is going to be something that we're going to use all through Algebra 1 and all through Algebra 2. So this is XY notation. This is so last week. Now we have this new thing called function notation. So what we write is the function. We use F. We can use any of the 26 letters. F is the common one because, oh, let's see, function starts with an F. And then we're going to put of X. What that means is I have a function and the variable I'm using is X. So if you look over here, what's my input? I'm going to put X in. I'm going to put a number in for X. I'm going to multiply it by 2. Then I'm going to add 3, and that's going to give me my output. Remember we said X is the input, Y is the output. And it's just going to equal whatever the rule is. And in this case, the rule was 2x plus 3. So basically, some people think of f of x as y in disguise. So when I want to find that, that means I am going to input 3 for x. So I'm going to look at the f function. This is the f function right here. The first thing I'm going to do is write 4. When I see the x, I'm getting rid of the x, and I'm keeping the plus 10. The function is the rule. It says take x, multiply it by 4, and then add 10. What is the input I want this time? 3. Now, this side is just what you're trying to find. You don't ever touch that side. You're going to manipulate the right-hand side. So 4 times 3 is 12. Then I still have plus 10. 12 plus 10 is 22. So what this says is the function. So f, the function f, when I input 3 for the variable, gives me an output of 22. In other words, if x is 3, y is 22. So now I want to look at the g function. So the first thing I'm going to do is I'm going to write the g function taking x out because x is the variable. It's the thing that's changing. It's my input. I'm going to write it as input squared plus 3 times input plus 2 because that's my rule. It says take whatever your input is, square it. Take your input, multiply it by 3, add that, and then add 2. Now in this case, what is my input? The input is -3. So I'm going to put -3 everywhere x is. Remember, x is your input. Now I'm going to do what my dear Aunt Sally says. She says -3 squared has to come first. Exponents come first. -3 times -3 is 9. Then I can add. What's 3 times -3? -9. Then I'm going to put plus 2. So 9 plus -9 is 0. I still have plus 2. 0 plus 2 is 2. Okay, This one is just weird. Isn't it weird that weird has E before I? Oh, I think that's so fun. What is my input here? The input is 2y. So I'm going to write the f function. The f function is 4 times the input plus 10. I got that? Let me erase it so you can see it from the rule right here. What is the input? The input is 2y. So anywhere there's an x, I'm going to put 2y. Now I'm going to multiply. 4 times 2y is 8y. Then I still have plus 10. I cannot combine like terms. Can't do it. So that is my answer. When I input 2y, my output is 8y plus 10. Whoa, little mind-blowing, little mind-blowing. Okay, so here we're going to do another one. These are our same things. F is still this, G is still this. It's just on a new slide, so we had a little bit of room. This time, look at how this is. This says 2 times G of A. Now, do you remember what your dear Aunt Sally says? She always says you have to do parentheses first. So that 2 is just going to hang outside. Inside, what does it want me to put? It wants the G function, but it's changing the input. So I'm going to write the G function a little bigger than what I had. I'm going to write the G function, leaving room for my input. What is my input? A. So outside, I still have 2. I can't go outside till the inside's cleaned up. Inside, a squared is just a squared. 3 times a is 3a, and then there's a plus 2. I cannot combine like terms. So now, what does my dear Aunt Sally say? After parentheses, I don't have any exponents, I'm going to multiply. This is the distributive property. 2 times a squared is 2a squared. 2 times 3a is plus 6a. 2 times 2 is plus 4. And that is my final output. Wow, this is a long video, but it's fun because we're doing functions. F. So for the F1, it doesn't have anything outside. It just says take the F1 and write it down. So I'm going to write it underneath because I don't have any room. So I'm going to write the F function, but remember, I'm leaving room for the input. You always take the X out and just put parentheses because X is what you change. What does it want me to change X to? What is my input this time? It's that entire 2 minus X. So what's my Aunt Sally say to do? She says, okay, multiply. 2 times 4 is 8. 4 times negative x is minus 4x. And then what's at the end? There's still a plus 10. Look, this time I can combine like terms. 8 plus 10 is 18, and then I still have minus 4x. Now these are a little confusing because inside the parentheses, that changes. Outside the parentheses stays there. So look at this next one. Negative 4 is outside. What is inside? The G function. So here's the G function. I just write the function. Now, what's my input? Oh my gosh, it was just x. They didn't want me to change it. So I still have this negative 4 outside. Inside, x squared is x squared plus 3 times x is 3x plus 2. And now I'm going to distribute. So that's negative 4x squared. Negative 4 times 3 is negative 12x. Negative 4 times 2 is negative 8. Little confusing when to input and when to leave it outside. Here's an idea. If it's outside, leave it outside. If it's in the parentheses, input it. Change the input. I bet we're getting to a checkpoint. There it is. So all of these are the f function. This is the f function. How should you rewrite that right off the bat? You should write it as 2 input minus 5. This is where your input goes. You get your input from what's inside the parentheses. This is outside, so you're going to do this. This is outside, so you're going to put your f function and then add your 6. Good luck. I already forgot the secret word. Hope you remember it. See you next time.